Jagadish, Sainath, hi.
Hi, sir.
Um, what's the last class? Hmm? We were done the descriptive statistics and inferential statistics, right? Let's talk about the population and sample from the introduction to statistics. Okay. So you already know that what exactly the population. Population means when you are doing one particular experiment. By the time if you're collecting all elements or all information, that we are calling it's a population, right? Yes or no? Here we have some kind of answers. Often in statistics, we are interested to collecting the data so that we can answer some research questions here. For example, what is the median household income in the Miami and Florida? So for example, you are taking one particular city, Florida. Okay, from that particular one.
Hello.
Yeah, hello. Yeah,
Hello.
we cannot hear the
Yeah.
sir. I think
Fine. Nice. Just I.
nice back online. Okay.
Okay, good enough. So here what I want to tell you actually, so when we are talking about statistics, we need to collect the data, right? When we are collecting the data, there is a two kind of okay, so there is a two kind of things we have it. One is the population and one is the sample. I think you already know about the population, right? So what exactly the population? Population means when we are taking the entire thing that we are calling it's a population from that particular entire thing, and when we are collecting entire whole information that we are calling it's a population. From that particular population, when we are considering some piece of information, that we are calling it a sample, right? Instead of collecting the data every individual in a population, we instead collect data in a sample of the population. We represent the portion of the population. We just taking some kind of portion of information from the population, that we are calling it's a sample. Population in the sense every possible individual element that we are interested in measuring, that we are calling it a population. Just we need to remember these two things actually. That's exactly population and sample. Okay, let's we have some kind of example. What is the mean household income in a Miami, Florida? Okay, here the entire population might be included 5 lakhs of households. In this particular city there is a 5 lakhs of households we have it. Okay, but we might only collect some portion of information, right? For example, you just consider only 2000 household information. So this is the 5 lakhs of household information which we are considering the population. And when we are taking only 2000 sample information, when we are taking 2000 okay, household information, that we are calling it a sample, right? This is one example. And we here we have also one more example. What is the mean weight of certain population of turtles, right? The entire population might be included 800 turtles, but we might only collect only 30 turtles, right? So this is your total turtles, and from that one we are just taking only 30 turtles. That in this particular situation, this could be the sample and this could be the population. Okay, and meanwhile, so here one more example. What is the percentage of the residents in a certain country support a certain law? For example, one particular country, we have one particular rule. Okay, we have one particular law. Okay, that law might be some people can be okay accepted and maybe supported, maybe some people, some portion of people, they are not supported, right? So for this particular situation, if you're collecting that entire country, there are 50,000 residents are there, so that is your population. Okay, from that one, instead of taking that all, we are just taking only 100 residents information only. Okay, that is the sample. Okay, clear? So now, so you might be thinking, I think so you understood what exactly the population and what exactly the sample, right? So why we require the sample, why we not collecting the population? So that's there are some kind of okay, important points are there. It is time consuming. For example, if you want to collecting the entire population information, it will be the time consuming or not? Okay, it is time consuming to collecting the data of the entire population, and that is the one thing. And when you're doing some kind of survey for entire population, by the time you need to invest a lot of money, so that it's a costly, okay, to collect the data from the entire population. So that's the reason we are investing some amount and we are taking some kind of sample data, and we are doing some kind of operation on the particular data, and it could be the replication of your population. Clear? And that could be the one thing. And in that next one is, it is infeasible to collect the, it is impossible. Even if you want to collect the entire population, it is impossible actually. Okay, so that is the 3 points. There are the 3 points. These are the 3 points which is okay, which these are the three reasons we are always working with the samples instead of the population. Okay, clear, right? Clear or not?
Yes, sir.
So so here the importance of the representative samples. When we are collecting the sample from the population, we ideally want to the samples be like a mini version or our population. So simple thing actually, it's a mini version of your population. Okay, so by the time, okay, so in this overall student, so we can read it, we can you can easily understand. For example, we want to understand the movie preferences of students in certain school district that has a population of 5000 total students. Since it would to long survey, okay, every individual, so you might instead take a okay, just 100 samples. If you want to collect the 100 sample information, that it could be easy, right? Okay, in this particular situation, it is overall student population composed 50% of the girls are there and 50% of the boys are there. Okay, our sample should not be representing the, okay, so it is representing the 90% of the boys and 10% of the girls only. That means in this particular city there are 50% of the girls are there, there are 50% of the boys are there, right? And you want to take some kind of review of that particular movie, whatever it is. Okay, by the time you took some kind of sample, 100 sample, out of 100 samples, 90 people you are took the survey from the boys only 10% of the people we are took the survey from the girls only. So that situation, your sample which is not replicating your population. Okay, see, so this is the population which we have the 50% for the boys and 50% for the girls, right? So but when you're taking the sample, when we are taking the sample, just mute, just one second. Okay, so here when we are taking the sample, but the sample which is just only 10% of the girls only, okay, only 90% of the boys of information only, 90% of the boys and 10% of the girls, which is replicating your sample. By the time your sample, it is not representing your population. Okay, so what, and some situations, and we have a lot of other things we have it. Okay, overall population equal part of the freshman and sophomores and juniors and seniors. In there our sample would not be representing if it is only included freshman. So here this is, so this population having the four different guys, right? So this red color and blue and green and some violet color we have it, right? So this situation, we are taking the sample, but only few same type of guys only we are taking. But what about other type of guys? By the time also your sample which is not representing your population. Okay, so that kind of situation, if you do any kind of operations on your sample, so which is never achieve your population information, that means you never say that confident about your results about your samples. Okay, so that kind of situations, our aim is that we need to do some kind of sampling. We have to go for apply some kind of sample techniques, so that we can replicating your sample with, we can replicating your population with sample data. Okay, there are many different methods we can use obtain the samples from the population. Okay, from the population for obtaining the samples we have different methods. So what are the methods we have it? To maximize these chances we obtain the representations, we can use one of the following methods, and simple random sampling. Simple random sampling. So simple random sampling in a sense, randomly select individuals through that use of random generator or some mean of random selections. Okay, so we have a population. From the population randomly we are selecting, and we don't know which sample, which portion, from which area we are taking that particular data. Okay, that is a simple random sampling. Second type of sampling technique is systematic random sampling. Put every member of the population into some order, choose the random starting point and select the every nth number to be in the sample actually. Okay, and stratified random sampling. Split your population into group and randomly selecting the some members from each group. See, this is the third type. Okay, these are the three different types. We have many other types we have it. So what exactly these three samplings are doing, I just explain it. Just give me 1 second. Okay, let it be a white paper. Okay, so simple random sampling. So for example, this is my population. Okay, this is my population. Okay, so we have different groups are there. This is group 1, this is group 2, this is group 3, this is group 4. Okay, and if you do the some simple random sampling, simple random sampling, by the time from this entire population randomly we are selecting 100 points. Okay, you don't know this 100 will be whether it is a group 1, might be maybe some things from the group 1, maybe something from the group 2, maybe something from the group 3, maybe some portion of information from the group 4, might not be also, because of it's a random, we don't know what order it is following. Just randomly you're picking some 100 samples. This is my population, it could be the 10,000. From the 10,000 samples you're taking from the 10,000 population, We're taking 100 sample randomly. This 100 could be anything, so that we are calling it a simple random sampling. Okay, and so we have some order. We can arranging this entire thing could be order format. So when you're doing order, so every nth numbers for this particular force, it is maybe we have a four groups are there. Even these four groups we have the 10,000, right? This 1,000 elements we are arranging in one order format, and we are taking the portions. It's not like portions, some elements, some nth elements wise we are taking. Okay, so some stepwise systematically we are taking. Okay, some systematic numbering we are considering. By the time maybe some group of elements can be considered, maybe some kind of group of elements with it could not be considered. Okay, but when you're applying the stratified sampling, for each group randomly we are selecting. So here we can select the 25, and here we can select the 25, and from this group we can select the 25, from here we can select the 25. So when you are doing the stratified sampling, for every group we are giving the equal chances, so that this 100 could be combination of this all groups. That could be the stratified sampling. That is the best algorithm actually, best sampling method. Clear? Even these things we can do practically. That's not a big problem. Okay, see, stratified random sampling, split your population into different group and randomly select the some members from each group. This is the good method actually. In each of this method, every individual in the population has equal probability of being included in the sample. This maximizes the chances that obtain the sample in the mini version of the population. So, and moreover, this is the sampling technique. It could be the best one. Okay, instead of comparing the systematic random sampling and simple random sampling. So this is the way you can representing your population and sample with we can collect the samples from the population with the different methods. I hope you guys are understanding what exactly the population and what exactly the sample, and how we can able to obtain the samples from the population also we understood, right? Now we can go ahead understanding the statistic and parameter. When we are talking about statistic and parameter, there are two important terms in the field of inferential statistics, that the first term is statistic and parameter. Okay, so the difference is that statistic is the number that is describing some characteristic of the population, sorry, sample. When we are describing the characteristics of the sample, that we are calling it a statistic, and we are describing some characteristics of the population, that we are calling it a parameter. Okay, that is the difference between a statistic and a parameter. Clear? And there we have some kind of examples, and commonly used statistics in statistics and parameters here. So we can do the population mean, or else so you just try to observe here. This is the measurements, right? So mean is my measurement. This is my one of the statistics, right? So this mean we can representing in a sample statistic is x bar. When you are the same mean for the population parameter, it could be the mu. Okay, standard deviation is also statistics only, but you can representing with the small s. And the sigma, it could be the standard deviation of the population. Okay, variance means it's s square for the statistic sample, and sigma square it could be the parameter, population parameter. And proportion, right? P is nothing but it could be the proportion, and that same thing we can representing with pi. And correlation, the sample correlation we can representing with r, and so population parameter for the correlation we can representing with rho. Okay, and regression coefficient we can representing with b, and population regression coefficient we can representing with b. So these are the representations for the population. These are the representation for the sample of the statistics measurements. Clear? So if you see this kind of representation, which means that which is talking about sample. If you see this kind of representation, that which is talking about population. Clear? Clear or not?
Clear.
Okay, so here we have some kind of commonly used statistics parameter. That's okay. And statistics versus parameter and practice problem, there could be some kind of examples here. And so this is one problem. Just read this problem and try to be observed. A researcher would like to find the mean wingspan, okay, wingspan of certain bird species. Okay, she collects the random sample 50 birds, measure the wingspan of each bird, and find the mean wingspan is 15.6 inches. So answer, the parameter that researcher is interested is measuring is the mean wingspan of the entire population of the particular bird species. The statistics in a sample mean which turns out of the 15.6. Okay. So here we have one more problem statement. An election council want to be understand the what portion of adults in a certain city or favor of one particular tax law. The obtained random sample. There are 1,000 people are there. Obtain and find the 30% of or in a favor in the law. Find that 34% of or in a favor of law. So answer, the parameter that the council is interested in measuring the proportion, okay, of all adults in the city who are the favor in the tax law. In a statistics, the sample portion which turn out to be 34%. See, if you see that particular problem, which thing it could be the population, which thing which is talking about sample, that we need to be understood actually. Okay.
So basically, if you have to simplify this, parameter is just basically an attribute that we are trying to calculate, and statistic is more like the derived value that we got out of the pop or the sample data.
Yep. So yes, absolutely correct. So this is your sample data. This is your population. Sorry, this is your population data. This is your sample data. Okay. So here also we can do the statistics. Here also we can do the statistics. Okay. But when you're doing the statistics on the population data, that we are calling it's a parameter. When we are doing the statistics on the sample data, the term we are calling it's a statistic. Okay. Clear? Good enough. Now we need to know that different kind of variables, and variables means which always hold some kind of information, right? So let's talk about different kind of variables we have it.
So is
So
there a mechanism to in statistics to understand what parameters within a population I would be interested in? I mean,
sorry, I can't get your point.
do you want me to repeat the question?
Yes.
What I'm saying is, I mean, understand what parameter and statistic is, but
Hmm.
how do you decide what parameter in that particular population is of interest for the analysis, right? Because you showed a table which had multiple parameters,
No, so
right?
you
So
see there are
how?
different parameters. Parameters and statistics both are same, both are talking about data only. Okay. But thing is that statistics is different. Statistics is different. Statistics means what? Finding the average, finding the standard deviation, finding the range, finding the min and max, finding the correlations. These are all things could be the statistics only. Okay. The same statistics we can apply the data, but the data is what is the matter. Clear?
Yeah, no, my question was slightly different. Let's say we are looking at the
Mm.
any population, right? For example, the example you had was the population of Florida, for example, right? There are many parameters I could be interested in analyzing, right,
Yes,
from
of
that
course we can do.
population. How,
Of course
how
we
do we decide or narrow down on what are the most critical parameters?
It
Is it
depends. It depends upon it depends upon your problem statement. Okay. For example, I said you find the average income of household, right? So here average is your statistic term. So here the parameter is population mean. Okay. And average is average of household, right? But we have sample data, and I want to find the mean of that particular sample data, that we are calling it as a sample mean. So here the population mean and sample mean both are statistics only. Here population mean is a parameter, sample mean is the statistic. So it depends upon problem statement which statistics we should go for apply on a population, which statistics we should go for apply in the sample. It depends upon your problem statement. Okay.
Yeah, I was just wondering if there is a, so for example, if I want to see a voter list
I
within
just want to tell
Florida,
you,
right?
I
What is
can
the
tell you.
average age of
I'm
voters?
just one second. Here, this is my data. Okay. And by the time of giving the data only, I said you this is population data.
Right.
I said you this is my population data, and the population data is having the two variables. This is my x variable and this is my y variable. Okay. find the correlation between the x and y. That particular situation, correlation is the statistics. If it is a population correlation, I can use the rho. So rho means it's a correlation only. Okay, so correlation means we are going to be finding the relationship between these two things. You might be getting the -1 to +1 only. In between this value only you might be getting. So the formula we have it, and you can Google it. We'll be getting the correlation formula. Okay. So here we are going to be getting the -1 to +1. -1 indicating that there could be a negatively strongly related, and the positive one in the sense those two are the correlation. There's two having the correlation, but it was in a positive correlation, strongly positively correlated. For example, my row I got the 0. That means this x and y there is no relation. Okay, but this is the data is the population, and I said you what is the relationship between these two things. What is the relationship between these two things? When you want to find the relation, then we can go for apply the correlation. If you want to understand this all things, definitely we need to learn lot of statistical terms, okay, that we can understand in a forward classes, like measure of central tendency, measure of variations. Okay, so if you want to describe the data, here we have it, right? Okay,
Okay,
here
okay,
we can
fair.
able to learn it, and meanwhile we can do some kind of see here we have it, right? So random variables, and so here we have it confidence intervals. Okay,
Got it. Okay, we
so
can go
everything
back to
here,
the.
these are all statistics only. These all statistics either we can apply in the population, either we can apply in the sample. These are all statistics only. These are all statistics we should go for applying the data, but the data is two types, right? Population data or sample data. So that's a what. These are all statistics we can apply on any data, whether it is a population or sample. Okay. Okay, so now we'll talk about the variables. Variables are always holding some kind of information, right? Okay, the information or the it can be holding some kind of data, right? So based upon the data we are holding into the variables, based upon the data we are holding into the variables, okay, there could be the two type of variables. One is the qualitative and second one is the quantitative. Qualitative in the sense it could be the characters. Quality, qualitative means quality. For example, I'm just giving some examples. um we went for some museum, right? Or else movie. Okay, I ask you a small question. What is whether the movie is good or bad or average or excellent? By the time what you can say, the movie is excellent, right? Or the movie is average, right? The movie is utter flop, right? Okay, there could be some kind of character quality. You're giving some kind of quality, right? Yes or no? Yes or no?
Yes, sir.
So here I'm talking about one particular movie. Okay, so you are the critic of that particular movie. Okay, so I just ask thrown a question for you. You've seen the movie, actually you saw the movie, and my question is what is your okay, rating, or else can you please tell me what exactly the movie is talking. Okay, by the time you're explaining about quality of that particular movie, the movie is excellent, the movie is good, the movie is bad, this kind of things we are calling it's a qualitative. Clear? Or else we have the five rating, 1 2 3 4 5 rating only. What could be the rating of that particular movie? So rating is also it's a quality. Okay, same thing. What could be the gross value or stock rate, a stock value of that particular movie? Okay, what could be the income of that particular movie in that particular day? So that we are calling it's a quantity. Movie is same, but you're talking about movie quality and we're talking about movie quantity. What is the budget of that particular movie? That is a quantity. The budget is high, the budget is low, the budget is medium, is quality. Okay, for example, if you want to do the movie, okay, you have some estimation cost. The cost is, for example, 100 crores. Okay, so that is quantity. Or else 50 crores or 60 crores, that it could be the quantity. So based upon you are investing into that particular movie, I can say uh, so the investment of that particular movie is extreme or else average or else very low or medium. This kind of things we're talking about quality of the budget. The quality of the budget, it was in a categorical that we are calling it say quantitative. Okay, we are talking about budget of the movie in numbers that we are calling it say quantitative. Clear or not? Hello, is it clear or any questions are there? So quantitative means something referred as the numeric number of students in the class, number of square feet in a house, population size in the city, age of the individual, height of the individual, right? So these are the examples of the quantitative. These are all 6 examples or 5 examples are talking about numbers only. Qualitative means something is referred to the categorical variable. Categorical variable in the sense, what is your eye color, what is the gender, what is the breed of dog, and level of graduation and marital statuses, everything it could be the categorical, right? Something it is in the format of string that we are calling it say categorical. Clear? There are examples or differentiation or so qualitative and quantitative. Definition: taken a numerical value that we are calling it a quantitative, taken in numbers, names or labels that we are calling it say qualitative. Okay, examples are number of students or number of square feet in a house. I think these are all we already seen in our previous example. Okay, so here we can see classifying the quantitative qualitative. For example, this is my Excel file. Okay, so this is a player name and position and seasons played, average points, championships. Okay, see, now tell me here what could be the qualitative, what could be the quantitative. Arvindo, can you please tell me? Player name is
Position is qualitative, and
position
the
is the
rest are
position is the qualitative, and player name is also qualitative. Okay,
yeah.
and the seasons played, number of seasons, which is talking about number of seasons he played, right? So that is a number. What could be the average point? That is also number. And total number of championships, that is also number, right? So there are 5 total variables in the data set. 2 of them the qualitative. What are those? Name, player name and position. Okay, so qualitative, player name and position is the qualitative, and seasons he played and average point and championships are the quantitative. Clear? Okay, so if you want to summarizing the quantitative and qualitative variables, make sure that we should go for using this. These are the concepts. These are this statistics only we are going to be using it. So if you want to summarize about your quantitative data, or if you want to summarize about your quantitative, so we can able to go for using so this measure of central tendency. So here measure of central tendency, measure of dispersion. Okay, however we can use only frequency table or relative frequency table for summarizing the qualitative table. See, we have the two kind of tables, right? One is the quantitative and one is the qualitative. If you want to describe about that particular data, we can use these two things for the quantitative: measure of central tendency and or measure of dispersion. This is the two things we can use for the quantitative data. And the frequency table only or relative frequency table only we can use for summarizing the qualitative data. Clear? Clear or not? I think Arvind, you can unmute your system and you are a little speed to understand. Okay, by my flow, so you can answer me for every situation. Okay. See, see here we have some kind of quantitative variable, right? Seasons he played. So on the seasons he played, we can apply the mean value, we can apply the median value, we can apply the mode, we can apply the range, we can apply the interquartile range, and we can apply the standard deviation. These are all your statistical terms only. These are all your statistical terms. Okay. So these are all things only we are categorizing into either measure of central tendency or measure of dispersion. Clear?
Yeah.
Yep. So for example, same thing. See here, this is my qualitative data, right? For the qualitative data, we can't apply the mean, median, mode, this kind of statistical things we can't apply. Okay. Only a frequency table we can apply. For example, G, it was repeated 4 times. F, which is repeated 4 times. C is repeated 2 times. So this is your frequency table. See here, this is the position. G is repeated 4 times. F is repeated 4 times, C is repeated 2 times, right? So this is the entire data. This is the column we are converting into frequency table. This is your summary of your qualitative data. Clear?
Okay.
Okay.
Yeah, I think so. Basically,
Hmm.
when we start looking at the sample set or the
Yeah.
population, we have to first identify which of these are qualitative
First,
and quantitative in nature, and
yes,
depending upon
absolutely. That
that,
is
we
the
can.
first step. Our first step is that when I provide the data set, whether it is a sample data set, whether it is a population data set, forget about it. Okay. Whether it is a population or sample, it doesn't matter for you. Okay. So if it is the population data, then you will be getting the 100% of the accuracy. If we have a sample data, might be there could be a chance of approximately 90%, not exactly 100. For example, you have the population data, we have a sample data, and you're doing the study on the population data, your result could be 100%. Your accuracy could be 100%. If you have a sample data, you're doing some kind of study on the sample data and you're giving some kind of results. That result, it is replicating the 100%, not exactly 100%. Might be there could be some kind of okay error, plus or minus 98 plus or minus or 100 98 plus or minus okay 2. That means there could be a chance of getting the 100 only 2%. 98 could be 50%, 96 plus or minus, so the result it could be in between 96 to 100. That means so there could be some kind of error when we are considering the sample. 100% there could be some error, but in population there is no error. Okay. Data can be anything. First thing is that we should identify which one is the qualitative, which one is the quantitative. Quantitative you can identify with a number, qualitative with you can identify with the characters, categoricals. Clear?
Yeah, I think we got that.
Okay. So this qualitative and quantitative only, again we can you can split into different okay measurements, that we can say that it's a measure of levels of measurements. In levels of measurements, okay, this nominal and ordinal are the qualitative. Okay, this nominal and ordinal, interval and ratio. So these are the levels of measurements. If it is the ratio, we can apply the all statistics. We can apply the all statistics, natural order, equal interval equal interval between variables, has the zero true value. The ratio between the value can be calculated. You can calculate the ratio between any two values. Okay. And it is a natural order, equal interval between the variables, and ordinal in the sense which just having the natural order. For example, see, I can give you some question. uh, okay, I can give you some question for you, right? So the question is, what could be the what could be eye color. So eye color is in order. First only red, second only green. Is there any order? Is there any order for arranging the color? Is there any
No,
color? Is there any order for the color? No, right?
no.
For example, you are you there could be a team. For example, there are 11 people are there and they are playing for one particular game, right? Okay. So there could be some order, right? First, this is the player need to be go. Second, this player, this third player, fourth player. So there are numbers only. 1 2 3 4 are numbers, but there are some order. That order kind of thing also ordinal. Okay. Okay. So equal intervals, for example, age group of people, so 26 to 56, that is one group, right? Age group, right? That is intervals. Equal intervals between the variables, for example, 10 to 20, 20 to 30, 30 to 40, 50 to 60, there could be some kind of equal intervals. Okay. So that's what. So temperature, it may be it may be less than the 0 degrees, right? Intervals temperature, For example for the temperature, something which can be lower value of 0, that kind of things we are calling its intervals. Something which is not less than the 0, that we are calling it's a ratio data. So you can easily understood what exactly nominal and everything. Nominal in the sense it's simply names, just simply names, nominal scale, and a scale used for label variables that have no quantitative values. There is no quantitative values. So example, gender, eye color, and hair color, blood type, and political preferences, place you live, which city you are living. This all examples for the nominal. Okay, and they have no natural order. Of course there is no natural order, mutually exclusive, and the only one number we can calculate it. So you just only go for finding the count of it. Okay, we can able to go for find the count of it, right? The only measure of central tendency we can calculate variables is a mode. So from the central tendency we just calculate only mode. Other than the mode we can't do anything. Okay, because of frequency table which is giving the how many times one particular element is repeated. So something which is repeated more, that we are calling it a mode. Okay, so if the data is the nominal, we can apply only mode from the measure of central tendency, and we can apply the frequency table. Other than this, we are not applying anything. Okay, what type of area you are living? So there could be some kind of city names, right? Okay, that all things we are calling it. There are possibility on the city or some rural area. Okay, that things we're calling it's a nominal. So ordinal in the sense something which is having some kind of order. The next type of measurement scale that we can use a label variable and ordinal scale. Okay, so natural ordinal scale in the sense the scale used a label variable that have a natural order, no quantified difference between the values. There is no difference. For example, um, grade or else rating. So rating of movie 1 2 3 4 5. So 1 2 3 4 5 are the qualitative. It's not qualitative, which is just numbers only. 1 2 3 4 5 also numbers, but which is having order. Okay, satisfactory, very unsatisfied, neutral, satisfied, and very satisfied. For the same thing we can providing the very unsatisfied, it could be 0 or -1. You can go ahead with -1. Unsatisfied in the sense 0. Neutral in the sense maybe 2. Satisfied in the sense 4. Very satisfied in the sense we can give the 5. So you can give some kind of numbers also for the same kind of things. Even those things also for seeing it could be the numbers, but it is following the order. Okay, socio-economical status actually, social economical status like low income, medium income, and high income, and workplace status or entry analyst or analyst 1, analyst 2, or lead analyst. There could be order, right? You cannot like go and do as work you are the fresher, but you cannot work as a lead analyst, right? First of all you have to start with entry level, then you have to get some experience. Then this is the way we are updating on your profile can change, right? There could be some order, right, for getting a lead position. Okay, a degree of pain. So small amount of pain, medium amount of pain, high amount of pain, that all things it could be ordinal. There could be some kind of order. Okay, they have some kind of natural order, and the difference between the values cannot be calculated. Is it possible difference between the satisfactory and unsatisfactory? It's not possible, right? If you want to difference between these two things, is it possible? No, right? So that is the thing which is saying the difference between the values cannot be evaluated. So we can do only two kind of measurements: measure of central tendency. So we can calculate it, these variables. One is the mode and second one is the median. These two more measure of central tendency things we can apply. Mode and median only we can apply on the ordinal data. Okay, so next one is there could be some kind of how satisfied were you with your most recent visit of your store. Okay, so these are the possible answers. Interval in the sense the next type of measurement is interval. So what exactly interval is doing? A scale used to label variable that have the natural order and quantifiable difference between the values, but true zero no true zero values. For example, temperature. Okay, so Fahrenheit and Celsius. Credit score 300 to 850, and sat score 400 to 1600. Okay, and these are the scores for these are the score for SAT score, credit score, temperature. These are all example for the intervals. So variables that can be measured in intervals, the following things. These are variables have the natural order. So we can measure the mean, median, mode, and standard deviation also we can apply. And these variables can have the exact difference between the values. Okay. For example, recall that ordinal variable has no exact difference between the variables, but if we don't know if the difference between the very satisfied and satisfied in the same way as the difference between the satisfied and neutral, for the variables and intervals, we know that the difference credit score of 850 and 800 exact same as the difference between the 850 and 750. There could be some kind of intervals, right? 850 to 750, and we can do the difference between these things. Okay, and no true zero value means it's impossible to have a credit score of 0. It is impossible to have the status score of 0 for the temperature. For the temperature, it's impossible have the it's possible have the negative values minus 10 degrees Fahrenheit, which means that is not a true zero. That values can't go below. It's can't true zero means the values not true zero. The values can't go below. It's the wrong explanation. This is wrong explanation. Median score, credit score, average income, and so ratio. The last type of measurement, it could be that ratio. So we can apply all kind of statistics: height, weight, length, these all things. The length length can be measured in centimeter, inches, and feet. Cannot have the value below 0. Is there anything below 0? Length of anything? Something which cannot below the 0, that is true 0. Something which goes below 0, that is no true 0. Weight, is there anything minus? Is there anything for height is a minus? Yes or no? Something
No.
which cannot go below 0, that we are calling it's a ratio. Something can go below 0, that we are calling it say intervals. Clear?
Yeah.
See, so this kind of properties we can apply. So has true 0 value. True 0 value means ratio. That means no one can value below 0. That is true 0. Can be 0, but cannot be below 0. Exact difference. So we can have a difference between these two things. Courses. Okay. Yep. So try to be complete this introduction to statistics from this statology, and so in the next class we'll talk about describing the data. That means measure of central tendency, measure of dispersion. These things we will talk about. Okay. Take care. Bye.
Okay, bye.